In this session, we're going to talk about different components and how to connect them to a Raspberry Pi Pico. In front of me, I've got a Raspberry Pi Pico H. I've got a breadboard. I've got a pack of resistors. I've got a pack of light emitting diodes, otherwise known as LEDs. And I have jumper cables. We've got two different types of jumper cables. You can see I've stripped one off of the set, and you can see that with this jumper cable, it's got a pin on both ends. This is what we call a male-to-male jumper cable. I'll strip off another one, and you'll notice that these are different. This has a pin on one end and a socket on the other end, which is a male to female jumper cable. So take note of the difference. Pins on both ends, pin on one end, socket on the other. When we are connecting components onto our breadboard to create a project, we need to make sure that we connect them in the correct way. So we'll look at how a breadboard works in the first place. You'll notice that there are many holes on the breadboard, and you'll notice that there are different sections on the breadboard. There are these two strips at the end, which are demarcated by a blue and a red line, blue and red line. And you'll notice that on the red line, there's a plus sign, and on the blue line, there's a minus sign. What these are used for is to create common rails. With every project you create, it will require you to have several ground connecting pins. And in order to create several ground connecting pins, you may want to connect a ground pin from a Raspberry Pi Pico or another microcontroller to one of these common rails here, so that you've got several take-off points for your components. We'll see what that looks like as we go along. So anything I connect in a pin there is going to connect to anything else that I connect on that line going downwards. So that blue line is all connected. All of these holes are connected. So that pin there is connected to that hole there and to that one there, and in fact any other hole there. But it is separate from these ones here. So if I connect this there, it's connected to anything else on that line. The same applies to this side. But please note that this side and this side are not connected. So even though we've connected something in the blue line there, it does not mean it's connected on that blue line, that side. It's only connected on this side. So these two are completely separate, but along that line, all of the pins are connected. Let's go to the center part of the breadboard. On the center part of the breadboard, we've got numbering going down. So you can see it's numbered 1, 5, 10, 15, and so forth. If you look very carefully, 1 is adjacent to the first line of holes. And if you count, 5 is adjacent to the fifth line of rows, and so forth. So you can see that we've got 60 lines up to there, 61 and 62. So we've got a total of 62 lines down that way. Also, when we look across, we've got letters A, B, C, D, and E on that side. Then that's demarcation. And then on this side, we've got F, G, H, I, J. How these work is that anything on a row between A and E is connected. So if I plug something into row 1 and column A, if I plug anything else into row 1 and column B, C, D, or E, those two things are connected. They are, however, not connected to anything on this side. So A is not connected to F, G, H, I, J. Row 1 is separate from row 2. So what that means essentially is these 5 pins A to E in row 1 are connected, but are separate from pins F to J in row 1. They're also separate from A to E in row 2, and so forth. You notice that the Raspberry Pi Pico you have is a Raspberry Pi Pico H. The H stands for headers, and these pins that we see at the back of the Pico are called the headers. These headers fit into our breadboard. You can line up holes of the breadboard with the pins of the Raspberry Pi Pico. Once you've lined them up like that, you need to push your component, in this case the Pico, until the black spacer is sitting directly above your breadboard. What we'd like to do at this point is to create a circuit with one light, a resistor, and jumpers, similar to what we did in the previous video, but this time using an LED that's not mounted on the Pico. What's important first of all is to know which pin we're connecting to. So I'm just going to extract the Raspberry Pi Pico from the board. This is going to be a bit difficult because it's firmly in place, but nudge it out gently so that you do not break the pins or the board. And if you look at the back, you can see we've got GP pins marked. We need to just take note of one pin where we're going to connect our LED. So I'm going to pay attention to this pin here, the top one, which is GP0, and the third pin is marked ground. I'll plug this back into our breadboard, and before I forget, I'm going to take our ground and put it onto a common rail. So third pin there, 1, 2, 3. Alongside that, it's in row 3, so I'm going to put a jumper cable in row 3, and then the other end of the jumper cable goes into our blue line. So that blue line there is now our ground. Then I'm going to take an LED. So taking this red LED, you can take any color as a matter of fact, but I just like red. If you look at the LED, you'll notice that one leg is longer than the other leg. When you're connecting an LED to a Raspberry Pi Pico, or in fact any other device similar to this, you need to note that the short leg is connecting to ground and the long leg is connecting to a numbered pin. So I'm going to connect the long leg to our numbered pin, which is pin 0. And the short leg, in this case, I'll connect it to our positive rail. The reason I'm doing this is because we ideally should have connected our Pico lower down so that we've got a few rows above to connect the short leg. But in any case, I'm going to connect that short leg into the positive rail. And make sure that as you do this, you're pushing the legs all the way in so that your components do not easily fall out. So you can see that ground is connected to that blue, and then the short leg of the LED is connected to red. These two are not connected, but to connect them, we need to put a resistor. A resistor protects the LED from burning out. So I'm going to take a resistor. In our case, we need a resistor which is in the range from 100 ohms to about 300 ohms. And from my pack of resistors, the resistors that I have within that range are 220 ohm resistors. So I'll just pull out one resistor from there. You can see the legs are straight. I'm just going to bend them over so that we can connect them to our breadboard. And then putting one leg into the ground and the other leg into the red. We have now created a circuit in which we have connected our LED to GP0, and we've connected it using a resistor to the ground.